Welcome to Chain Rule Day 2. This day is going to be more not with defined functions ahead of time. It's going to be dealing more with graphs and tables and predetermined values. So let's get this thing started here. If a function whose graph is shown, which is right here, it's kind of hard to tell in the video here, but I'll highlight some important things here as we go through it. And this should be nicely printed out in your notes. This is the point -3, 3, and this is the point 3, 3, and this is the origin right there. So h of x be f of x and g of x be f of x squared. Use the graph to estimate the value of each one. So we need to find h prime of 2. So first off, we need to find h prime of x. So we have a function inside of a function here. Okay, so the outer function is this first f, so we're going to find the derivative of that. So it's just going to be f prime, leave the inside alone, times the derivative of the inside, which is just going to be f prime. So at this point, it's all notation. Okay, and then what we're going to do here is we're going to plug in a 2 now. So h prime of 2 is going to be f prime of f of 2 times f prime of 2. And now let's go ahead and do this. F prime of f of 2, well, where's 2? 2 is right here, and then the height is also 2, and I know this because this has a slope of 1 from the origin, so that's going to be 2 right there, times, and then f prime of 2 is actually just going to be 1. So that's the slope. So the slope right here equals 1. So then f prime of 2 again becomes 1. So it's 1 times 1, which is indeed 1. Okay. For g, I'll do g in a different color. I'll do it in red. For g prime, I'm going to do the derivative of the outside. Again, the outside function is f, so it's going to be f prime. Inside stays the same, times the derivative of the inside, which is going to be 2x. And I need to plug in a good old 2. So I'm going to get g prime of 2 is f prime of 2 squared, which is 4, times 2 times 2, which is 4. So now looking at 4, which is right here, this slope right here, if you can count it, is rise -1 over 1, so it's going to turn into a -1. So this is -1 times 4, which is -4. So that's evaluating those on a graph. Now, let's suppose that we're just given some values of this. So suppose that we have w, which is u. That's not a time sign. That's a composition sign. U of v. And we have these initial points. Not going to read them all out. We're going to find w of 0. So first things first, w is equal to u of v of x. Okay? With that notation, a little bit easier to see the chain rule now. So the derivative of the outside is u prime v of x times derivative of the inside, which is v prime of x. And now I need to plug in a good old 0. So w prime of 0 is equal to u prime of v of 0 times v prime of 0. So when I do this, u prime of v of 0, which is right here, is 2, times v prime of 0 is right here, which is 5. U prime of 2 is right here, which is 4, times 5 is a big old 20. Okay. Next up is a table. This table didn't print out really nicely, so you can't really see it on here so much. I'll highlight what is important here. If you have your notes printed out like you should, then this should not be a problem. I'm reading it off of yours. So use the table to estimate the value of h prime of 0.5. So right here is 0.5, and I'll kind of highlight these values here. And this is x's, this is f of x, and this is g of x. So you can see it a little bit better on here. So let's go do this. So h prime of x is going to be f prime of g of x times now the derivative of the inside. Okay. So now I need to do this with 0.5. So h prime of 0.5. And this is an approximation because I'm not going to have all of these values, and you'll see what we do in just a moment here. So f prime of g of 0.5 times g prime of 0.5. Now, I don't have g prime of 0.5. I'm actually going to need to use the secant of the points around it. So let me go ahead and highlight those for you so it's easier to read on here, because this is the only values I'm using. That's supposed to be a 4. And then this is a 0.6. This should be a 4. It's a little better, like a 4. Okay, so now, before I do g prime of 0.5, I'm going to go ahead and just plug in this g of 0.5. So this is going to give me f prime of g of 0.5 is actually 0.10. So 0.10 times g prime of 0.5. Now I don't have the values of 0.10, but I'm using this right here. So I'm going to use the secant of the two values right around it. So I'm going to use the 0.2. I'll do that in red as well. So I have a 0.2. Sorry, most of this is just me tracing. Have your notes in front of you. This should not be an issue. So anytime you estimate a slope, you always find the secant of the 2 points immediately around it. You don't jump around. You find the ones that are immediately around it. So let's go ahead and estimate here what f prime of 0.10 is. And again, I'm estimating because I can't find the exact value. So I'm going to do f of 0.2 minus f of 0 all over 0.2 minus 0, which is going to give me 18.4 minus 12.6 all over 0.2. And that's going to give me, when you do all the math, 29. Okay. And then let's go ahead and estimate g prime of 0.5. That's going to be g of 0.6 minus g of 0.4 all over 0.6 minus 0.4, which is going to be 29.1 minus 25.9 all over 0.2, and that is going to give me a, when I do all this math, oh, I used the wrong values, I just noticed. I was like, okay, that's a little off. No worries, we'll fix it. 0, you know what, we'll just fix it right here. I used the wrong values. I'm supposed to use this right here. So 0.05 minus 0.17 all over 0.2, and that's going to give me, it looks like, negative 0.12, divide that. You're going to get a negative 0.6, I believe. Okay. So now when I translate over here, this is an approximation because I don't have these exact values. It's going to be 29 times negative 0.6, and that's going to give us approximate value of negative 17.4. Okay, so this problem involved definitely chain rule, then some secants and approximations, which is super important. And that's going to wrap everything up here for chain rule day 2.